Welcome to Nardar Academy. In this video, we are going to discuss about properties of definite integrals and few problems using these properties. Okay, first let us see what are the important properties about definite integrals. The first one is integral a to b phi of x dx is equal to integral a to b phi of t dt. This means here x is the variable. No, if you change the variable x into another variable t, that won't affect the value of the integral. Okay, that is the variable of integration may be replaced by any other variable, right? Next one is integral a to b phi of x dx is equal to integral a to c phi of x dx plus integral c to b phi of x dx. Okay, that is the limits from a to b can be split into two parts, one from a to c, another one is from c to b. Then the third one is integral a to b phi of x dx is equal to minus integral b to a phi of x dx. That means if you change the limits of integration, then the sign will be changed. Okay, a to b, here the limit is a to b, here the limit is b to a, then the sign is changed to negative. Next one is integral a 0 to a phi of x dx is equal to integral 0 to a phi of a minus x into dx. This is one important property. See here the integrand is phi of x integral. Here the integrand is changed into phi of a minus x. Okay, that is integral 0 to a phi of x dx is equal to integral 0 to a phi of a minus x into dx. The next property is integral 0 to 2a phi of x dx is equal to 2 times integral 0 to a phi of x dx when phi of 2a minus x is equal to phi of x. But when phi of 2a minus x is equal to minus phi of x, the value of the integrand is equal to 0. These two properties we will be using for integrating trigonometric functions. These two will be very useful for those problems. Okay. Then next one is integral minus a to a phi of x dx is equal to 0 when phi is an odd function. Odd function means what? That is the functions when you apply minus x instead of x, it will be negative of that function. So for odd function, the value of the integral equal to 0. For even function, the integral is equal to 2 times integral 0 to a phi of x into dx, right? Okay, so these are the 6 important properties. So you have to remember all the 6 properties. So they will be very helpful for doing integration problems. Now let's see few problems. First one is evaluate integral 0 to pi x into sin x power 6 cos x power 4 dx. Okay, right. So whenever you have trigonometric functions inside the integral sign, you try to apply any one of the properties of definite integrals. Here I am going to make use of phi integral 0 to a phi of x dx is equal to integral 0 to a phi of a minus x dx. Why should I use this formula? Because you see the integrand here, if it is simply sine power 6 and cos power 4, we can make use of reduction formula. But when x is there, no, so if this x is not there, I can make use of reduction formula. So for removing this x, this formula will be very helpful. Now let me apply this formula here. So for applying this formula, I is equal to integral 0 to pi. Wherever you find x, you replace it by pi minus x. Here because in the place of a we are having pi, no, so replace it by pi minus x. Pi minus 6 sine power 6 of pi minus 6 and cos power 4 of pi minus x. Okay, then what happens? Pi minus x into sine of pi minus x, sine of 180 minus theta is equal to sine theta, and cos of 180 minus theta equal to minus cos theta. But here it is even power, no, so power, when you raise the power to 4, it will be plus only. So pi minus x sine power 6x into cos power 4x dx. Now already I have the given question, I have taken the given question as equation number 1, and now this is equation number 2. Both are I only, the same integral only. So let me add both the integrals 1 and 2. So if I add 1 and 2, I get 2i is equal to this sine power 6 and cos power 4 are common for both the integrals. So I am taking it outside. Sine power 6x and cos power 4x, take it outside. So inside it will be x plus pi minus 6. So x will get cancelled, only pi will come. Pi is a constant, so I can take it outside the integral sign. For this purpose only I am applying that property. Okay, right. So now I am getting the integral as 2i is equal to pi into integral 0 to pi sine power 6 into cos power 4x dx. Still again here I cannot apply the reduction formula because I have the reduction formula readily available when the limits are from 0 to pi by 2, isn't it? So for changing this, again I am going to make use of the property integral 0 to 2a phi of x dx is equal to 2 times integral 0 to a phi of x dx. But this is applicable only when you have phi of pi minus x is equal to phi of x, isn't it? So let's see what is phi of pi minus x. This is the integrand is my phi of x. No, phi of x equal to sin power 6x into cos power 4x. What about phi of pi minus x? Replace all x by pi minus x. So sin power 6 pi minus x, cos power 4 pi minus x. This is again sin of 180 minus theta is sin theta, cos of 180 minus theta is minus cos theta, but since the power is 4, it will be again plus. So sin power 6x into cos power 4x. So phi of pi minus x is equal to phi of x. Therefore, this formula I can apply. So I am applying this formula to this equation. So what happens? 2i equal to, instead of the integral 0 to pi, I am applying 2 times integral 0 to 2 pi. See here, limit from 0 to 2a. After applying this property, it will be 2 times integral 0 to a, isn't it? In the same way, here originally the limit from 0 to pi, after applying the property, it will be 2 times integral 0 to pi by 2 sin power 6x into cos power 4x into dx. Okay, now I am going to apply the reduction formula. For applying reduction formula, already I have uploaded 2 videos. One for deriving the reduction formula for all the trigonometric functions, and another video for how to use reduction formula for doing problems. You can see those 2 videos for your reference. Now here, see, the power of sine and power of cos both are even numbers. In that case, when both are even case, you start with power of sine function. Okay, 5 no, in the numerator, that is 6 no, in the numerator you have to start from 5. 5 into 3 into 1, up to 1 you proceed, 5 into 3 into 1. How many terms are there? Only 3 terms are there. For denominator, you have to take sum of the 2 powers. 6 plus 4 is what? 10. You start from 10, reduce 2 by 2 and write only 3 terms. In the numerator you are having 3 terms only, no? The denominator also you should have only 3 terms. So 10 into 8 into 6. Beyond that you should not go. Okay. Into cos power is also even, no? So here for this 4 you have to write 4 here, no? So in the denominator it will be 4 into 2, in the numerator it will be what? 3 into 1, into both are even, no? So into pi by 2 should come. So this is the reduction formula for sin power 6 into cos power 4. So after simplifying, I am getting it as 2 into 3 pi square by 512. So I equal to simply 3 pi square by 512. Okay. Next problem. Evaluate integral 0 to pi by 2 square root of sin x by square root of sin x plus square root of cos x into dx. Okay, right. Now let me make use of the formula. Integral 0 to a phi of x dx is equal to integral 0 to a phi of a minus x into dx. So here the limit is what? Pi by 2. So here this integral will become, after applying this property, this will become I equal to integral 0 to pi by 2 square root of sin of pi by 2 minus x by square root of sin of pi by 2 minus x plus cos of pi by 2 minus x. This is sin 90 minus theta is cos theta and cos 90 minus theta is sin theta. Okay, so this will become integral 0 to pi by 2 root cos x by root sin x plus root cos x dx. So now let me add both the integrals. So for both the integrals, the denominator is same, no? So 2i equal to integral 0 to pi by 2 root sin x plus cos x. In the numerator again you will get what? Root sin x plus root cos x. So both of them get cancelled. So simply you have integral 0 to pi by 2 dx. So very complicated integral now reduced to a very simplest form, isn't it? Okay, so if you integrate, you will get x within the limit 0 to pi by 2. Now apply the limits, upper limit pi by 2 minus lower limit is 0. So simply 2i equal to pi by 2 or I equal to what? Pi by 4. Next problem, evaluate integral 0 to pi x sin x by 1 plus cos square x into dx. Again, I am going to make use of the formula 0 to a phi of x dx equal to integral 0 to a phi of a minus x into dx. Okay, so if you substitute, what happens? I equal to integral 0 to pi minus x into sin of pi minus x by 1 plus cos square pi minus x dx. So pi minus x into sin of 180 minus theta is sin theta and cos of 180 minus theta is minus cos theta, but you have square, so it will be plus cos square x. Now you add the given integral and this equation. So 1 plus 2 gives 2i equal to sin x by 1 plus cos square is a common term, so you take it outside. So you have pi minus x plus x. X get cancelled, so simply you have pi, which is a constant, you can take it outside. So simply what you are getting, 2i equal to pi into integral 0 to pi sin x by 1 plus cos square x. Right. Next, For trigonometric, evaluating trigonometric function, if I have the limits from 0 to pi by 2, it will be easy for my calculation. So I am going to make use of this formula, integral 0 to 2a phi of x equal to 2 times integral 0 to a phi of x. But this is applicable only when phi of 2a minus x is equal to phi of x. This you need not to do it separately. Already this is what we have done here. Okay, that is in the place of x I have replaced it as the limit minus x. Here what is the limit? Pi minus x only I have replaced. No, after replacement also I got the same function. So here this is true. Okay, if you want you can check it again, but I am not going to check. The reason is already I have done the same thing previously. Okay, so this is true, therefore I am applying it here. So 2i equal to, here instead of limit 0 to pi I am changing it as 2 times integral 0 to pi by 2 sin x by 1 plus cos square x. Now for doing this integration I am going to make use of substitution method. Here 1 plus cos square I am having, no. So let me take t equal to cos x. Then dt equal to minus sin x dx, isn't it? Now let us see the limits. Here x varies from 0 to pi by 2. When x equal to 0, t equal to cos 0. Cos 0 equal to what? 1. When x equal to pi by 2, t equal to cos pi by 2. Cos pi by 2 equal to what? 0. So 2i equal to 2 pi integral 1 to 0. Instead of sin x dx, I have to substitute minus dt by 1 plus t square. Here minus sign is there, no. So let me interchange the limits. Here 1 to 0, no. So instead of this minus sign, I am changing the limits from 0 to 1, dt by 1 plus t square. What is integration of 1 by 1 plus t square? Tan inverse of t. So tan inverse of t within the limit 0 to 1. Now apply the limit. So 2 pi into tan inverse of 1 minus tan inverse of 0. What is tan inverse of 1? Pi by 4 minus tan inverse of 0 is 0. So 2i equal to 2 pi square by 8, or simply what? I is equal to pi square by 4. Okay. Next problem, evaluate integral 0 to pi by 2 sin square x by sin x plus cos x. Right. So as usual I am going to apply the property integral 0 to a phi of x dx equal to integral 0 to a phi of a minus x into dx. So if you substitute, what happens? Integral 0 to pi by 2 sin square pi by 2 minus x by sin pi by 2 minus x plus cos pi by 2 minus x. So sin of 90 minus theta is cos theta, no. So cos square x by, this is cos x plus sin x. Now you add equation 1 and 2. So what you get? 2i equal to, denominator is common. In the numerator what you have? Sin square x plus cos square x. But sin square plus cos square equal to simply 1. So I am getting integral 0 to pi by 2 1 by cos x plus sin x. Right. Okay. Now for evaluating this integral, it's not possible to do direct integration. So what I am doing is I am going to multiply and divide throughout. See, if any integration problem is given, you can do in so many different ways. The problem can be solved in different ways. Here I am following one method. Okay, this will be easy for you. See, here this is cos and this is sin. No, I am multiplying and dividing by 1 by root 2. Okay, so multiply by 1 by root 2 and divide by 1 by root 2. So it will come here, no. So 1 by root 2 cos x plus 1 by root 2 sin x. What I am going to do this 1 by root 2 is, instead of this 1 by root 2, I am going to write it as sin pi by 4. And instead of this 1 by root 2, I am writing it as cos pi by 4. So this will take the form sin a cos b plus cos a sin b, isn't it? What is sin a cos b plus cos a sin b? It is nothing but sin of a plus b. So instead of this full term, I can write it as sin of pi by 4 plus x. Okay, so simply it is 1 by sin. 1 by sin means what? Cosecant. So it is equal to cosecant of pi by 4 plus x. So my integral is now 2y equal to 1 by root 2 integral 0 to pi by 2 cosecant of pi by 4 plus x into dx. But the formula for integral cosecant of ax plus b dx is equal to 1 by a into log tan of, I missed to write tan here. So log tan of ax plus b by 2. So here for this problem, a is coefficient of x is 1 and b is pi by 4. So substitute this formula here. So 1 by root 2 into, right, 1 by a, no, 1 by a here is 1 because x coefficient is 1. So 1 by 1 log tan of ax plus b. What is ax plus b here? X plus pi by 4 by 2 within the limit 0 to pi by 2. Now apply the limits. First upper limit is pi by 2. So log tan of pi by 2 plus pi by 4 by 2 minus log tan of, instead of x you put 0. So it will be simply pi by 8. So it's equal to log tan of, this will be 3 pi by 8 minus log tan of pi by 8. This is like log a minus log b, which can be written as log of a by b. So log tan of 3 pi by 8 by tan pi by 8. Okay, again this 3 pi by 8 I can write it as pi by 2 minus pi by 8. Okay, what is tan of 90 minus theta? It is cot theta. So this is cot of pi by 8 by tan pi by 8. What is cot theta? Cot is nothing but cos by sin and tan is nothing but sin by cos. So it will be simply cos square pi by 8 by sin square pi by 8. So what I am getting 1 by root 2 log of cos square pi by 8 by sin square pi by 8. So cos square theta, instead of cos square theta, I can, because I don't know the value. If they are standard values, I can substitute the values and I can simplify. These are not standard values, so I am doing substitution by substitution. Cos square theta equal to 1 plus cos 2 theta and sin square theta equal to 1 minus cos 2 theta. So you substitute it here. 1 plus cos 2 pi by 8 will be what? Pi by 4. Here 1 minus cos 2 pi by 4 will be 2 pi by 8. It will be cos pi by 4. Cos pi by 4 is 1 by root 2, no? So it's equal to 1 by root 2 log 1 plus 1 by root 2 by 1 minus 1 by root 2. If you take LCM, it will be 1 by root 2 log root 2 plus 1 by root 2 minus 1. Okay, now we take conjugate. So it will be 1 by root 2 into log of root 2 plus 1 by root 2 minus 1 into root 2 plus 1 by root 2 plus 1. So if you multiply the numerator, it will be root 2 plus 1 the whole square. Denominator, it is of the form a minus b into a plus b. It's a square minus b square. So 2 minus 1. So 1 by root 2 log of root 2 plus 1 the whole square. You bring this 2 to this side. So it will be 1 by root 2, 2 log root of 2 plus 1. So 2 get cancelled. So 2i equal to root 2 log root 2 plus 1, or simply I equal to 1 by root 2 log of root 2 plus 1. Okay. Next problem. Show that integral 0 to pi by 4 log of 1 plus tan theta d theta equal to pi by 8 into log 2. As usual, let me apply the property. Integral is 0 to a phi of x dx is equal to integral 0 to a phi of a minus x dx. So applying that property, I am getting 0 to pi by 4 log of 1 plus tan pi by 4 minus theta into d theta. But tan of a minus b formula is tan a minus tan b by 1 plus tan a tan b. So here tan pi by 4 minus tan theta by 1 plus tan pi by 4 tan theta. Put tan pi by 4 equal to 1 here. So log of 1 plus 1 minus tan theta by 1 plus tan theta d theta. Now you take LCM. So it will be 1 plus tan theta plus 1 minus tan theta. So tan theta get cancelled. So simply log 2 by 1 plus tan theta d theta. This is of the form log of a by b, which you can write it as log a minus log b. Okay, so this, if you do integration, it will be simply log 2 into integral 0 to pi by 2 pi by 4 d theta. And this is our question, given the question, isn't it? Integral 0 to pi by 4 log of 1 plus tan theta. So instead of this, I can write it as simply I. Okay, so I equal to log 2 integral d theta minus I. Bring all the i's together. So 2i equal to log 2. If you integrate this, theta within the limit 0 to pi by 4, so it's equal to pi by 4 log 2. Therefore I equal to what? Pi by 8 log 2. Okay. Next one, evaluate integral 0 to pi cos power 2n plus 1x into dx. Here this is like my see, only cos function is there. I can apply reduction formula. For applying reduction formula, I must have the upper limit as pi by 2, no? So for that I am checking what is phi of pi minus x. This is phi of x. Phi of pi minus x is equal to cos power 2n plus 1 of pi minus x. But cos of 180 minus theta is minus cos theta. Here the power is an odd number. So it will be simply minus cos power 2n plus 1x. So phi of pi minus x is equal to minus phi of x. But if we know the property, integral 0 to 2a phi of x dx is equal to 0 whenever phi of 2a minus x equal to minus phi of x. Therefore, the value of this integral equal to 0. So whenever you see 0 to 2 pi cos power any odd function, any odd number, you can simply write it as what? 0. Okay, then next problem, evaluate integral 0 to pi x dx by 1 plus sin x. Let I be the given integral. Now as usual, let us apply the property integral 0 to a phi of x dx equal to integral 0 to a phi of a minus x dx. So it will be pi minus x by 1 plus sin into pi minus x. So every time, why do we apply this property? Because you see this integral here in the numerator, you are having x, no? So with this x, we cannot do the integration directly. We want to eliminate this x. For that, this property will be helpful. That is why we are, every time we are applying this property. Now you add these two. Equation 1 and 2 you add. So what will you get? 2i equal to integral 0 to pi by 1 plus sin x. Okay, right. Now you take conjugate. 1 minus, multiply and divide by 1 minus sin x. It will be 1 minus sin x by 1 minus sin square x. This is cos square x, no? So 1 minus sin x by cos square x. So split it into two terms. So 1 by cos square x is secant square x minus sin by cos square x is secant x into tan x. right? Integration of secant square x is tan x, and integration of secant x tan x is what? Secant x. Now we apply the limits. Tan pi is also 0 and tan 0 is also 0. So the first term will be entirely 0 and the second term is secant pi minus secant 0. Secant pi is minus 1 minus secant 0 is 1. So minus 1 will be what? Minus 2. So here and one more minus is there, so it will be plus 2 pi. So 2i equal to 2 pi or simply I equal to pi. Okay, that's all. Thank you.